This is GCSE Further Mechanics. We're looking at UVAST, constant acceleration formula, and we're looking at vertical motion under gravity. A ball is thrown vertically upwards at 9 meters per second. The thrower's hand is 2 meters above ground level. Find how long it is before the ball hits the ground and the speed with which it hits the ground. We can do this in different wee sections. We can split it up into 3 wee bits, or we can kind of take it all as one. I think I'll probably take it all as one, so let's write that. This can be taken as one motion, since acceleration is constant throughout. Or we can split it into sections. I'll probably try and do both here. I'm going to be doing all on a separate sheet. So taking it all as one motion. So what's happening here? Let's draw up kind of a vague picture so we can see what's going on. It's been thrown up in the air, kind of from 2 meters in the air. It reaches a certain height and then it comes down and hits the ground. And that distance there, then it's going to be 2 meters. So that's what we're trying to work out. I'm going to take upwards to be positive because that's the original position. So U, V, A, S and T. It was definitely thrown upwards at 9. So that's 9. V, we don't know. Acceleration is minus 10 because acceleration is definitely going 10 that way. S, where do we want to work out its displacement? We want the displacement at minus 2. That's quite a tough one to get your head around. But the displacement has to be minus 2. So there's our information, and we're going to try and work out then the time. So S equals ut plus a half at squared minus 2. So this tells us when it's at minus 2 is equal to 9t plus a half minus 10t squared minus 2 equals 9t minus 5t squared. We have a quadratic here. I'm going to rearrange it, take everything over to this side. 5t squared minus 9t minus 2 equals 0. This does factorize. If you want to do your 4 lines of working out to do that, that's okay. It's going to be 5t upon t and plus 1 and minus 2, which is quite handy. That gives us 5t plus 1 equals 0. Or t minus 2 equals 0. That means 5t is minus 1. Obviously that gives us t is minus a fifth, which is impossible. Sort of. And then t equals 2. So therefore hits ground after 2 seconds. Let's do the same thing again, only we're going to split it into its 3 sections, and just to see how it works. We'll just do a kind of quick run through of this. But the sections, it gets thrown up and then kind of comes down to here, where that distance there then is going to be 2. And if we split this into section 1, section 2 and section 3 and work out the time then for those, U, V, A, S and T. And for section 1 then, U is 9, V is 0. That's a key point there. So as it heads up this way here, whenever it reaches the top, it instantaneously comes to 0. If you throw a ball up in the air, it gets slower and slower and slower until it hits the top, and my V then is 0. Now A is minus 10, S we don't need to worry about, and T is what we're looking for. So V equals U plus AT, V equals 9 minus 10T, 10T is 9, and T then is 9 tenths. For section 2 we can do something quite clever, and we can use symmetry. Therefore T is 9 tenths as well. This goes up here. It takes the same time for it to go up as it takes to come down and hit that point there. So if it takes 9 tenths of a second to get here, it takes 9 tenths of a second then to get here. Section 3, we can use information we know as well. U, V, A, S and T. Of course, remember, we're using different information. Here I took work upwards to be positive. Apologies, I should have had a big arrow. Because it's now going down, I'm going to take downwards to be positive. If it was doing 9 here, it's now doing 9 there. 9, acceleration is 10, and my distance is 2. And we're trying to work out our time. U, A and S, and we want our time. So S equals UT plus a half AT squared. Funny, it'll come out to be nearly like an opposite quadratic. 2 equals 9T plus a half 10T squared. 2 equals 9T plus 5T squared. 5T squared plus 9T minus 2 equals 0. 5T T plus 2 minus 1, I think makes that one work. That means 5T minus 1 equals 0, or T plus 2 equals 0. Right, like the quadratic we see before. That gives me T is a fifth, or T is minus 2, which I can discard, doesn't make any sense. So for part 3 of the journey, it takes a fifth of a second. 9 tenths plus 9 tenths plus a fifth. And that gives me 2 seconds. It's probably a slower method. I think it's clearer. I think it makes more sense. And again, it's good practice to see how these things work out. Whenever the thing hits the top there, that tells you that its velocity is 0. We can use symmetry for the second bit. We know if it's going 9 upwards here, it's going 9 downwards at this point here. And it's good to get that sort of information. Okay, on to the second part of the question then. And it kind of works for both. So the speed with which it hits the ground is what we need. So we're going to use v squared equals u squared plus 2as. Now we're back to using our original information here, where we've taken it all in as the one journey. So let's go for that. V squared equals 9 squared plus 2 upon minus 10 upon minus 2. And v squared equals 81 plus 40. V squared is 121. And v then is plus or minus 11 meters per second. Since we took upwards to be positive, weirdly the one we want is minus 11 meters per second. Therefore hits ground at speed of 11 meters per second. Again, we could take fact, not to confuse you too much, just this third journey here, 9, and then the speed, it kind of speeds up, then it kind of hits with 11. We could use the third part of the journey and use this information here. We'll come back just to kind of use everything. Okay.